Morning, Year 12. I hope you're well. I'm not sure if this lesson's in the morning. Yes, it is. I got that right. Okay, so last lesson, we were looking at the rate equation. And just to recap, the rate equation is equal to the rate constant, and it is multiplied by the concentrations of whatever the reactants are. I've called them A and B there. Okay, remember the square brackets means it's a concentration. Now, today we're going to have a look at how we can, from experimental data, how we can work out whether it is zero order, first order, or second order. And what this basically means is what effect does it have of changing the concentration of a reactant on the rate. So if it is zero order, the rate will not change. It will be constant. If it's first order, if you double the concentration of a reactant, then the rate will double. So that is first order. And if you double the concentration of a reactant and the rate quadruples, I can't spell, then it is second order. Okay, so how do we find out the order? We need experimental data, and I've got a sample here of some experimental data. We've got two reactants, sodium hydroxide and A, and in the question it tells us that A is an ester. We don't need to worry what type of ester it is. So the first thing we need to do is look to find the order for sodium hydroxide, some experimental data. We've got 4 different experiments here with different concentrations where A's concentration stays the same, and that is experiment 2 and experiment 3. But we can see that the initial concentration of a sodium hydroxide does change, so we need to look at how much does it change by, or more to the point, the factor it's increased by. So going from 0.04 to 0.06, we are multiplying by 1.5. So now we need to look at the rate and see how that changes. And going from 6 times 10 to the minus 4 to 9 times 10 to the minus 4 is an increase by a factor of 1.5. So that is the same as doubling the concentration and the rate doubling. Therefore, we can say that this is first order with respect to the sodium hydroxide. It's a really important sentence, so you need to duplicate that. So now we need to find the order with respect to A. So we need to have a look here for some data where the concentration of sodium hydroxide is constant, and that is experiment 1 and 2. And we can see the concentration of A changes. So we need to look at how much it increases by, what factor it increases by, and that is also times 1.5. So let's look at the rate. We're going from 4 times 10 to the minus 4 to 6 times 10 to the minus 4, which is an increase by a factor of 1.5. So again, we can say this is first order with respect to A. Brilliant. Now, we need to work out the unit of the rate constant, K. So we need to rearrange this equation. So K equals the rate, let me move this up, sorry about this, divided by the concentration of sodium hydroxide times the concentration of the ester A. Now plug in the units for these. The unit of rate is the change in concentration per second. So it's mole per decimeter cubed per second. And this is all divided by mole per decimeter cubed times mole per decimeter cubed. We can cancel out those. Now we need to tidy it up. So we need to move a mole per decimeter cubed to the top. So that means the signs invert, so it becomes mole to the -1, decimeter cubed, seconds to the -1. Easy. Now I just want to show you one more example. So we have got a different set of data here. So this is for experiment. We've got A, B, and C of the reactants, and I want to work out the order of B. So looking at this data, we need to find two experiments which we can compare where the concentration of A and the concentration of C do not change, but the concentration of B does. I think you would agree we're going to use the experiment 2 and experiment 3, and we see here that the concentration of B doubles. Then we have a look at the effect this has on the rate, and if you can't do this in your head, just divide this by that and it will tell you the factor it's increased by, and you will find out that it has increased by a factor of 4. Therefore, it is second order with respect to B. Okay, that's enough of me feeling stupid filming myself. Attached are some questions which I want you to work on. They get gradually harder, but that's life. Take care. Bye-bye.